This is the AALogic Cable Fault Locator Kit. It's used to locate resistive faults in cables. The kit includes a transmitter, receiver, cable clips for the transmitter to connect to the cable pair, chargers, and a hand coil for use with the receiver. A test set like the AALogic D105 is used to determine the type of fault, how much resistance is in the fault, and what is the length of the cable. You'll need to know whether you're looking for a cross, a split, a short, or in some cases a ground. Grounds are more difficult to locate, so if one of the other types is available, choose it. We'll begin with the ST101 transmitter. In fault location, we begin by connecting a transmitter to the faulted pair. On the front panel we have two charger indicators. These tell you that the charger is plugged in and has power on it. It also can indicate when the battery is actually charging. On the display area, there's a battery charge indicator on the top left-hand corner. We always recommend that you begin with the battery fully charged. You can also operate with the charger plugged in if you have AC mains available. Along the bottom row of the display, you'll see labels. This one indicates manual, that corresponds with F1 key. Auto set corresponds with F3 key. Right now, F2 key is not being used and there's no label. As you operate the ST101, the labels will change for the function keys as you go to different functions of the set. There's a frequency key that allows you to manually change the frequency that's being transmitted. The level key allows you to manually change the output level, how much voltage is being put on the pair. The config key allows you to change settings like the display. The power clear button turns the power on and off. It's a long key press to turn the power on or off. It also serves as a clear key or an exit key from any function that you're in the transmitter. The supplied 12-volt charger is plugged into this connection. On the right hand side there's an output port. You connect the pair cable with the clips to connect to the faulted pair. The auto set function is the easiest way to set the transmitter up for fault location. Our test fault today is 100 ohms short across the pair, so the clips will be connected across the tip and the ring. For grounds, crosses, and splits, refer to the user's manual for the proper connections. Connecting the clips, the tip and the ring don't really matter which way we connect these. We just want to make sure that we have a good connection. The transmitter will be sending the frequency out on the tip and the ring, and we're only concerned about current flow. So the tip and the ring is not really important. We're now ready to start the auto set function. That's F3. We're going to press F3, which is labeled auto set. Transmitter prompts you to connect the output, which is the clips. We've already connected those to the pair. If you hadn't connected them, you would do that now and press start to begin the process. The ST101 will scan all the available frequencies and voltages, trying to find the best match for this cable pair. The best match depends on the length of the cable and the amount of resistance in the fault. When the scanning is complete, you'll get a frequency indication. In this case, it's 335. This number is important because it's also set on the Snoopy receiver. Pressing OK will begin transmitting. You should know that the transmitter is capable of sending high voltage out on the cable pairs, so be careful about touching the clips. Press OK to start sending. On our display, we see that 335 is selected. That's the transmit frequency. Our power level indication is 10, that's maximum power. And we have a relative indication of how much power is being sent. It's 0 to 15. It doesn't have a value, it's just stronger it would be a bigger signal and weaker would be a smaller signal. You can stop transmitting if you'd like by pressing F1. You might do this if you have to work on the cable or do something, make the connections. To restart transmitting, press F1 start. Transmitter goes back to the same frequency in the previous power setting. Frequency can be manually changed by pressing the frequency button. On this screen you can use the F1 key to move down the list and the F3 key to move up the list. We'll increase the frequency to 987. When you have the proper frequency select, you'll press set, which is F2. Notice on the display that the recommended cable length is also shown. For 987, the recommended cable length is from 2 to 5,000 feet of cable. Press set. The transmitter is now sending 987, and it's also at the same power level as before, power level 10. Notice that the relative power output is significantly less. This may mean that with the receiver you may not have enough signal to trace the tone. We'll set the frequency back to 335. Now our indication is back to 335 and power level 10. We're going to decrease the power level. To decrease the level manually, you just press the level key. And again, we'll use F1 to decrease and F3 to increase, then press set. We'll decrease the power level to 8 and press set. Once we press set, the transmitter will go back into the send mode. We have a slightly lower relative power output signal. With the transmitter properly set, we now take the receiver and monitor the signal very close to where the transmitter is installed. We set the receiver to the same frequency as the transmitter and ensure we have a good signal for tracing. The ST101 transmitter also has a manual mode. It may be useful after using the auto set and you want to resume a locating process. You might also use it if you already know the frequency and the power level you want to use. To determine the best frequency and power level, you'll need to know approximate distance to the fault and also how much cable is beyond the fault. The ST101 provides some assistance in trying to determine the best frequency. Press Config and F3 for help, and you'll see a list of information for aerial faults. For each frequency, there's a far end length and a resistant fault value. This is the recommended highest resistive fault given a specific far end length. Let's look at this example. For 335 Hertz, with 1,000 feet beyond the fault, we can expect to find faults up to 15,000 ohms. If we have 2,000 feet beyond the fault, we can expect to find resistive faults up to 8,000 ohms. And with 5,000 feet beyond the fault, we can expect to find resistive faults up to 3,000 ohms. The reason this is important is because the longer the distance beyond the fault, the more carry by there is. A high resistive fault is going to have more of a tendency to carry by into the distance beyond the fault. So this is a recommendation for trying to determine the frequency that you want to use. Press F3 and it'll go to 987. We see comparable information for each one of these. These are not absolute values, they're just recommendations to help select frequencies. Press clear to go back to the main menu. On the main screen we see that the current frequency is 987. If you want to use that frequency, all you have to do is press F1 manual to begin. If you want to change the frequency, press the frequency key. A list of frequencies are shown on the left hand side. You move up and down the list using F1 to move down and F3 to move up. Also, as the frequency is indicated, there's also a recommended distance. So 987 Hertz is recommended for use for 2,000 to 5,000 feet of cable. This is the total length of the cable. To check 2,000 Hertz, we can see that for 2,000 Hertz, the recommended length is 1,000 to 3,000 feet of cable. There is some overlap. If we move back down to 987, we can see that 2,000 feet, the low end of 987, is the middle of the 2,000 Hertz. You can choose whichever one you want to start with, and if that's not acceptable, you can change and use another one. Once you've selected your frequency, you press Set, which is F2 key. And that sets your frequency for the main screen. You're now ready to start. Press F1 manual. The ST101 will prompt you to connect the clips to the fault. Press F1 to start. In some cases, the ST101 will warn you of a high resistance error and check the pair cord. This is in the event that the clips are not connected properly to the cable pair. This message may be displayed for some types of faults on some cable pairs. To continue, press OK. We now see that 987 Hertz is being sent, power level 10, and we have a relatively low power output setting. We can change the frequency to try to increase the amount of power out. Press the frequency key to go to the frequency screen. We're currently at 987. We'll use a lower frequency. Press F1 to select 335 and press Set. Our power level is still at 10, but you can see that the relative power going out on the cable is much higher. This means we'll have a stronger signal and make it easier for us to trace the fault using the receiver. We'll change the frequency again. Press frequency. We'll select 145 Hertz and press Set. Again, we see a stronger power output indication. To change the power level, press the level key. We're currently at power level 10. We can decrease that by pressing F1 down arrow key. To increase, we press F3. We'll decrease the power level to 7 and press Set. Power level is now 7. You can see a decrease in the power out. The best way to determine if the frequency and the power level is adequate is to use the receiver to monitor the signal on the cable. This is the SR101 receiver. It's part of AALogic's cable fault location system. We're going to go through the setup and locating of a fault. This is a test setup. We have about 100 feet of cable. We also have a fault on the pair. The fault is 1,800 ohms. The transmitter has already been set up on the cable pair. Review the video on setting up the transmitter for more information. Also, these videos do not replace the user guide. Additional information about use of the equipment is available in the user guides. The cable fault location system can be used for buried cable and aerial. This example is for aerial cable faults. If you have equipment, it may be helpful for you to follow along as I go through this demonstration. The SR101 is operated by the power clear key and the F1, 2, 3, and 4 keys along the bottom of the screen. In the top left corner is a battery charge status indicator. We recommend you always start with a full charge on your unit. We're going to be focusing on aerial faults today, and that's the F3 key. Anytime you want to leave any of the screens for the SR101, press the clear key. The hand coil is connected on the right side of the SR101. Two hand coils are available for the SR101. One is a hand coil, the other one is a coil for mounting on a pole. Once the transmitter is set up, it's a good idea to use the SR101, the receiver, and check to make sure that you have a strong signal. We're going to start by pressing aerial. For this short cable and for the fault that we have, we've selected 2000 Hertz at the transmitter. Right now we have 145 Hertz set. We're going to use the F3 key to move the selection up to 2 kilohertz. I can now hear a faint signal coming from the speaker. It's not very loud yet. We'll move the hand coil over to the cable, and we can see that we've got a much stronger signal. On the display, you can see it's going all the way to the top. We want to adjust the gain. So to select the gain, we'll press F1 key until the gain is selected. Now we can use the F2 key to reduce the gain. So we see the signal is moving along a little bit less than mid-screen. We're going to move the hand coil on the cable, and you can see that it dropped and came back up. This is a normal process. I'm just moving the hand coil back and forth across a short piece of the cable. The faulted pair is twisted inside the cable. Sometimes that cable is near the surface where the hand coil is, and sometimes it's near the bottom. This affects the strength. When the pair is close to the top, closer to the hand coil, the signal will go up, and when it's on the other side, it'll go far away. Ideally, we'd like to have a signal that has a good variation, highs and lows, but stays on the screen. We don't want it to go off the top of the screen, nor do we want it to go off the bottom of the screen. The current signal shows in this corner 43%. That's the current level right now. This test would be done near the transmitter right after the transmitter is set up. If you need to adjust the gains on the receiver, you want to do it before you start trying to locate the fault. You can also increase or decrease the power at the transmitter if necessary to get a good signal on the receiver. Once you begin coiling, it's important not to change the gain on the receiver. That will give you a false indication. If you lower the gain too far, you may lose the signal and think you found the fault. If you increase the gain too much, you might wind up with a high signal and have too much signal on the receiver due to carry by of the signal past the fault. So it's important to get the gain set on the receiver and then try to leave it alone. Make all of your changes before you start locating. Once you start locating the fault, move the hand coil along the cable. You should see a rise and fall. If you don't see that rise and fall, something's wrong. It should not be flatlining as long as you're between the fault and the transmitter. Once you've determined that you have a good signal, you can move to another point farther away from the transmitter and coil again. Each time you coil, you should see a rise and fall in the signal. If the volume needs to be adjusted, it's either too loud or too soft, press the select key F1 until volume is highlighted, and then you can move the volume up, make it louder, or you can move it down and make it softer. There's also two sound options. This is the natural sound mode. This is what the signal actually sounds like, and we also have a simulated option. And this is generated by the computer. The signal strength is based on the original signal strength. For higher frequencies, the simulated may be easier to hear. As we move the hand coil closer to the fault, we're still seeing that we have the rises and falls. When we move into the faulted area and past the fault, we can see now that I'm past the fault, the signal is extremely low. The indication on the screen right now is 2%. As I move the coil on the far side away from the fault, we don't see any rise and falls, and in fact, we don't even see any signal. At this point, you do not want to change the gain and look for the signal. If you're not sure if you've found the fault or not, simply move back to a point that you believe is between the fault and the transmitter. You should see the signal again. Verify you have the proper signal by moving it along the cable. It should move up and down. Move it back past the fault to a location beyond the fault, and you should see a signal that's greatly diminished or no signal at all. The farther we get away from the fault, the less signal we're going to have. I've now changed the frequency to 987 Hertz at the transmitter. First step is we're going to change the frequency on the receiver. We have frequency selected, and we'll go to 987. Then we'll move the coil up to the cable and listen for tone. You can hear that this tone is a lower pitch, and we can see that we have a nice baseline tone to check with. This is showing about 42%. We're going to move it along the cable and make sure we see the rise and fall. We can see a rise and fall as we move along the cable. You would want to complete this step again near the transmitter to ensure that you have a nice traceable signal. Move along the cable, find a point, and trace. Make sure that you have that rise and fall. We're going to move closer to the fault. Again, we have a nice rise and fall. This is a point just beyond the fault. We still have some tone, but it's very, very weak. Let's compare the tone before the fault. The signals we're showing here on the peak side is running about 63. Let's go on the far side. And the strongest tone we see here is about 7. Very, very big difference between the tone before and after. The farther we get from the fault, the less tone that we're going to see. This is confirmation that we've actually passed the fault. Again, to re-verify, we can place the coil, go to a point before the fault location, verify we have a signal, move to a point beyond the fault, and we should see a significant difference in the cable. This is for a short. For a cross, the clips are connected to the 2 wires that are crossed, and the display will look similar to what you saw for the short. For splits, the clips are connected to the 2 split wires. The far end has to be shorted. The display will show a low signal until you pass the fault, and then you'll see a large increase in the signal. Ground faults are more difficult to locate due to the cross-coupling of the signal to adjacent pairs. If the cable has a short or a cross, it's better to locate those. To locate the ground, connect one clip to the wire, the other to the sheath. Coil carefully, as there will be a lot of cross-coupling. The signal should decrease when you pass the fault. However, the decrease may not be as significant as you saw in the short. Careful coiling is required. Thank you for your interest in the cable fault location system. More information is available in the user manuals. Please contact AALogic for any questions. Thank you.